Hello, this is the assignment 3 solutions. Question 1, solve the following triangles using only sine and cosine law. Find all missing angles and side lengths, 3 points each. Something I should have put in here, but I did not, was that you're also allowed, and sum of interior angles. So this is what we discussed in class. Sometimes you need this one for depending on what you were given for the triangles. So we will need that for the first one, not for the second one though. It will be useful for this. Future questions have their wording revised. The reason I worded it this way was just so that I didn't want you using any primary trig ratios from last week's assignment. I wanted you to only use the sine and cosine laws. I was a little bit too strict with my wording here, clearly, because I did not convey what I meant, so my bad. Anyway, the first triangle here. I'm going to go ahead and just use sine law here to find this missing angle. I will call A. So sine A over 3.8 is going to be equal to the sine of 115 over 10.25, and multiplying everything by 3.8, get the sine of A is equal to 3.8 times the sine of 115 over 10.25, and taking the inverse sine of everything, I get the inverse sine or the arc sine of 3.8 times the sine of 115 over 10.25. There we go. And running this all into my calculator, I get 5 let's call this 19.6 degrees. Now, as covered in class and in the bonus question of assignment 2's video, we will end up using the sum of interior angles here. So we know that 180 degrees is equal to all the angles added up inside here. So that's going to be 115 plus angle A, which is our 19.6, plus angle B, that last missing angle there. So angle B is equal to 180 minus 115 minus 19.6. So that means angle B is equal to 45.4 degrees. Okay, 45.4 degrees. Lastly, we can use sine law one last time to find the last missing side length of B, and this will be equal to 10.25 over the sine of 115. And sorry, that is not the sine of B. That is the sine of 45.4, what we just calculated. Multiply everything by the sine of 45.4, and we get 10.25 times the sine of 45.4, all over the sine of 115. And this is equal to something that I will punch into my calculator. And I got, let's call that 8.1. And our units are in millimeters. Okay, great. So that was the first triangle. for this page here. Now I'm going to go ahead and just divide my page in half here. Nice and quick. Just to keep these separate. Okay, second triangle. I'm going to call this side C, call this angle A, call this angle B. And I'm going to start with my cosine law for side C there. So C squared equals A squared plus B squared minus 2AB times the cosine of angle C. Writing this out, I'm going to move my square root over. I'm going to square root everything, both sides. And let's plug in some numbers here. So my A side length is my 9.52. And that's squared. My B side length is 8, again squared, minus 2 times 9.52 times 8. And this is the cosine of 30 degrees. Plugging all of this into my calculator. First, I will hit my square root, then 9.52 squared plus 8 squared minus 2 times 9.52 times 8 times the cosine of 30 degrees equals 4.77, and we have units of millimeters. So when I was reading out that line of when I was punching in numbers to my calculator, I was saying the exact buttons I was pressing on my calculator as I pressed them. This is because I was asked to be a bit more descriptive with what exactly I'm punching into my calculator. So if you need, go on back, listen to what I say, and punch in exactly what I say. You should get the correct answer, punching those numbers into your calculator in that order. So that was our side length C. Let's go ahead and find angle A using sine law. So that gives us sine A over my 9.52 is equal to the sine of 30 degrees over the side length we just found, 4.77. And now we can go ahead and solve for sine A. Multiply everything by 9.52 times the sine of 30 all over 4.77. And now I take the inverse sine of everything. Okay. So again, I will be descriptive with what buttons I press on my calculator for this calculation all in one go. So first I'm going to hit my second function. Some of your calculators, that might be shift. Then I will hit sine, so I get my inverse sine. Then I'm going to open a bracket, and I'm going to hit 9.52 times sine 30 divided by 4.77, and now I'm going to close the bracket. Now I hit equals. And I got 86. Let's call that 0.3. I'm noticing something. I should have solved for that one later, but we will see. We will see why shortly. Let's go ahead and solve for angle B. Again, we are not allowed to use this. Well, we are allowed to use the sum of interior angles, but we're not going to for this one because we don't need to. I'm going to find B first, the exact same way I just found A. So sine B over 8 is equal to the sine of 30 over 4.77. And using the exact same rearrangement for finding the angle A, We are also going to have our angle B here. And using pretty much the exact same inputs, we are going to get an answer of, let's just call that 57. 57 degrees. So, if we take all these angles and add them up, what are we going to get? So if we take 57 plus 86.3 plus 30, we should get 180. So what do we get? 57 plus 86.3 plus 30. Uh-oh, that doesn't get us what we need. That gets us 173.3. We are short. And that's not just because of rounding. This is because of how the periodic functions work. And this is because the angle A is actually greater than 86. It's actually greater than 90. So if we go ahead and cheat just a little bit here, we will see that if we ignore this, oops, that wasn't supposed to happen. If we ignore the 86 one, and we instead write this as 180 minus 57 minus 30, we will see that we need an angle of 93 degrees. So that is what angle A has to be. So we know that A has to equal 93 degrees. The reason why is because these are periodic functions. The sine function is a periodic function, which means it's a wave. It goes on like this. Repeats, repeating pattern. And let me just zoom in a little bit on this. And so what that means is basically that if you are trying to find where this function is equal to a specific value, it is actually going to be equal to this specific value an infinite number of times. It'll be equal to it over here as well, off the edge of the screen. Again, a third time. But what your calculator does, and what mine does, is it finds this first value. It finds whatever the first answer is, and it tells you that, oh, hey, this happens at 86.3 degrees, when this peak is actually at 90 degrees. And this next one is at, and you might have guessed it, 93 degrees. So what's happening here is your calculator is just giving you the first value. It's the first possible solution, positive solution, I should say. It's the first possible solution that satisfies the trigonometric function of the sine function. However, that first answer of 86.3 does not satisfy our triangle here. So we must take the next one, which is 93. And so because of rounding, what I should actually have said is that this should be 87. So I'm going to call this 87. And this will make sense in a second as to why. Okay, so if your calculator gives you 87 and you realize that this is just wrong, it is not enough, it ends up being 6 short, we get 74 instead of 180, 174 instead of 180. What you do is you find this difference here. You find whatever is made up, or whatever number you need to add to get to 180. So in our case, that is 174 plus 6 equals 180. We know that angle A has to be the obtuse angle. It is the largest of them all. So that is the one that has to be over 90. So I'm going to add 6 to it. I'm going to get 87 plus 6 equals 93. And that is where my A equals 93 degrees comes from. On the back over here on the graph, what that means is that this distance and this distance are both equal to 3. Or this whole distance between them is equal to 6. So it is because it is past that first 90 degrees. So that was question 1. A little bit more involved than you may expect. Question 2 here. Solve for the sag height of a plano concave lens with a radius of curvature of 800 millimeters. So that's an R of 800 millimeters. And a diameter, that is the full diameter, of 100 millimeters. And we are asked to find the sag height, so H equals question mark. Looking for our formulas over here. We are going to be using this one boxed in blue. So let me copy that and paste it over here. That's the formula we're going to be using. So I get H equals the radius, so that's 800 millimeters. I will not include units here, save a bit of room, minus 800 squared minus, now this D is not the full diameter. D is equal to phi divided by 2, which is 100 divided by 2. So D is actually 50 millimeters. So this is 50. Again, not putting units in this. 50 under the square root there. And this gives us an H of, I think it was 1.56, but let me punch these numbers into my calculator just in case. Yes, 1.56. Again, this was all done in millimeters. Okay, so that was our answer for number 2 there. Number 3, a plano convex lens has a diameter of 6 centimeters. That is 60 millimeters. We get a bulge height of 1.2 millimeters. And we're asked to find the radius of curvature. So from our formula sheet, we are going to need this formula over here. And again, we are going to have to find our half radius D, or half diameter D. That is going to be 60 divided by 2, or 30 millimeters. So I get 30 squared over 2 times 1.2 plus 1.2 over 2. And this gives me a radius of curvature of something that I have to plug into my calculator. I punched something in wrong, so I need to redo that. I just hit the wrong button. I accidentally multiplied by 12 instead of 1.2. So bear with me for a second here. And I got 375.6 millimeters. So that's the answer for number 3 there. Number 4, solve for the diameter. So that's our unknown of a plano concave lens with a radius of curvature of 400 millimeters and a sag height of 1 centimeter, which is also 10 millimeters. On our formula sheet, we will be using this guy. So, my full diameter is equal to this here and the full diameter comes out to be I will call that 178 millimeters. Okay, so those were the answers for 2, 3, and 4. On to the next one here. A plano convex lens is having a milling machine set up on it. The machine has a diameter of 10 centimeters or 100 millimeters. The radius of the diamond tip is 7 millimeters, and the desired radius of curvature for the lens is 0.15 meters or 150 millimeters. Calculate the setup angle, alpha, required for this lens. Okay, so we know that this is going to be the sine of alpha equals something. And we are told this is convex, so we are going to take this formula here and use this. So sine of alpha is equal to my 100 millimeters over 2 times the radius of the lens, so that's my 150 plus my 7, all multiplied by 2 in the bottom there. And of course I have to take my inverse sine of all of this. And I simplified a little bit in the denominator there. Just a little. And punching this in my calculator, I get I'm getting 18.6 degrees. So that is the setup angle for that question. For part 6 here, a plano concave lens. So it's basically the same, except we're just going to need the concave formula instead this time. Is having a milling machine. So a plano concave lens is having a milling machine set up on it. The machine has a diameter of 4 centimeters, so that is 40 millimeters. From the tip of one diamond to another, the radius of the diamond tip is 2 millimeters, and the desired radius of the curvature of the lens is 0.05 meters or 50 millimeters. And again, we are asked for the setup angle alpha. So the sine of alpha is equal to our 40 divided by the 2 times 50 minus 2, this time taking the inverse sine of everything, and again simplifying the bottom just a little bit. I get something. I am punching into my calculator. I get 24.6 degrees. Did I forget to put degrees on my prior answer? Nope. Okay, we're good. So that was the assignment 3. That was all of it. Thank you for watching, listening, whatever. If you have questions, please email me or ask me in class.